Hi, my name is Arnaud Legal and I'm a CSE for Aruba. And in this session, I will cover a new feature coming with AOS-CX 10.12, VLAN-aware Bundle Service, or so-called single tenancy. So first, the agenda. So as usual, we will cover the following topics. First, an overview of this new feature. Then we will move forward with the different use cases as well as the details and the caveats. We will then see how to configure it, the best practices, and the troubleshooting part. And to conclude, we will have a demo and we will discuss about scalability and performance numbers. So let's start with the overview and what is VLAN-aware Bundle Service. First, a little bit of acronyms. So we already know the vast majority of those acronyms, but here we will focus on three specific ones. The two first have already been mentioned in previous TOI. So EVI or EVPN instance, which represents a broadcast domain shared between several VTEPs. MAC VRF, which represents the table storing all MAC addresses learned for a given EVI. And the third one, which is something new coming with VLAN-aware Bundle Service, Ethernet Tag ID, which is a VLAN identifier carried in the EVPN routes. Let's move on with a reminder. So before AOS-CX 10.12, the only way to configure EVPN and the related EVIs was using the VLAN-based service. So using this type of service, it means that each VLAN has its own EVPN instance. And doing that, each VLAN has its own MAC VRF table. And so now, regarding the Ethernet Tag ID, even if it's present in the NLRI, it must be set to 0 in all EVPN routes. So if we take an example, we can see on the left how EVPN is configured on a switch running AOS-CX 10.11. You need to declare all VLANs associated with the layer 2 VNI and to declare on a per VLAN basis a route distinguisher as well as route targets we want to use to import and export EVPN routes. And when it's required, we also need to enable the host route distribution, which is a requirement for symmetric IRB when you have to advertise host routes to remote VTEPs. This configuration gives the results you can see on the right of the slide, especially the details for a given EVI, but also the show EVPN MAC IP command, allowing to show which MAC are reachable for a given EVI and so for a given broadcast domain. But now, starting with AOS-CX 10.12, we support a new kind of EVPN implementation or EVPN service named VLAN-aware Bundle. On a pure data plane perspective, the VLAN to VNI mapping remains fully available, and it allows to keep isolation between VLANs. But the differences between EVPN services are more focused on the control plane and how EVPN works. So with VLAN-aware Bundle, you can now have only one EVI, one route distinguisher, and one route target common to multiple VLANs. Secondly, unlike VLAN-based service, the Ethernet Tag ID must be set. It cannot be 0. And finally, each VLAN will have its own layer 2 bridging table inside the EVI's MAC VRF table, and they are identified by the Ethernet Tag ID. This implementation is compliant with the RFC 7432, which describes all types of EVPN services. Now let's look at those diagrams comparing VLAN-based and VLAN-aware Bundle services. So on the left side, we can see how VLAN-based service handles broadcast domains and forwarding tables. So each EVI, which can be identified thanks to the route distinguisher, only supports one broadcast domain, so one VLAN. On a forwarding perspective, each EVI will also have its own MAC VRF table, represented by the route targets, allowing to import routes and to identify the routes we send using route target export. But now, using VLAN-aware Bundle, each EVI supports multiple broadcast domains, and the associated MAC VRF tables also support multiple layer 2 bridging tables identified by the Ethernet tag ID. Now let's move forward with the use cases. So first, the main use case for this new capability is a matter of interoperability with other vendors. Before 10.12, as we already mentioned, AOS-CX only handled VLAN-based services. But because VLAN-based and VLAN-aware bundle cannot interoperate, we were not able to create fabrics with other vendors which were implementing VLAN-aware Bundle Service. This is due to how both services handle Ethernet tag ID and map, store the MAC addresses and information in the MAC VRF and the bridging table. So now, with AOS-CX 10.12, we can interoperate with other vendors such as Arista or Juniper. The second use case is focused on configuration simplification. Using the VLAN-based service, we need to declare each CVI individually, so each VLAN with their route target, route distinguisher, and options. So when we have dozens of services to declare, the task can be very tedious, and the readability of the configuration can be difficult as well. Now, with VLAN-aware Bundle Service, we can group several VLANs into the same bundle, so into the same EVI. This allows to configure route distinguisher, route target, and options only once for all the group, and simplify the configuration and the readability. And finally, the third use case allows to get a better organization. As bundles allows to group VLANs and to take any kind of name, it becomes very easy to better organize services per group or per topic. So as you can see on the slide, we've made two examples. So the first one groups VLAN per type of environment. So as an example with production and pre-production, and the second one grouping VLAN per tenant. So here we have tenant 1, and you can see another group, so another bundle called tenant 2. Now let's see the details and the caveats. So let's start with the first batch of details. So the first point to note is that VLAN-aware bundle is used only for layer 2 VNI. As we are working with VLANs, and so EVIs, it means that layer 3 VNI are not part of this process. The second part of this slide is regarding route target and route distinguisher. As we already mentioned, those items are common to all VLANs assigned to a bundle. So what does it mean exactly? So first, it means that in order to keep isolation between broadcast domains, each MAC VRF will have a separate table for each VLAN. Secondly, the route target used with Ethernet tag ID is used to identify this layer 2 bridging table in which the new MAC address must be stored on the egress VTable. And the third one is the fact that with a bundle, the option auto is no longer available. So we have to use manually defined route distinguisher and route targets inside a bundle. So it's not because we don't have the option auto anymore in the VLAN-aware bundle that it's not available for the VLAN-based configuration. It's still available, obviously, when you have to configure VLAN-based services. So now let's take a look at BGP routes and how it can illustrate the implementation of VLAN-aware bundles. So if we first look at a route type 3, we can see the following elements. So obviously, we will find the standard elements of a BGP EVPN packet, so the route target that we can find in the EVPN configuration, as well as doing a show BGP L2VPN EVPN command on the remote VTEP. The VNI as well, obviously, the route distinguisher, and finally, the Ethernet tag ID, which is not set to 0, but with a value that we define within the bundle configuration. Doing a show BGP L2VPN EVPN command, we also find this value for each entry, allowing to identify the layer 2 bridging table. Looking now at the route type 2, we can find the same kind of information with the Ethernet tag ID, which is here, just right here, which is not set to 0, but to the VLAN ID. Coming back on the details, we also have to mention that when you configure a bundle in the EVPN configuration, the name of the bundle is purely local to a VTEP, but it has to be unique inside this same device. So two bundles cannot share the same name into the same device. One key thing also is the fact that we cannot have a broadcast domain between VTEPs having a VLAN-aware bundle on one side and VLAN-based service on the other side. Why? Because of the Ethernet tag ID. VLAN-based service will always set the Ethernet tag ID to 0, while VLAN-aware bundle will always use an Ethernet tag ID which must be different than 0. And so if we try to set up a broadcast domain with those two kinds of services, VTEPs will not be able to match the layer 2 bridging table. And finally, VLAN-aware bundle doesn't have any functional impact on existing configuration. So layer 3 VNI configuration remains totally unchanged. And because VLAN-aware bundle is an EVPN capability, everything related to the VXLAN interface remains also unchanged. Now, regarding the multi-fabrics context, so VLAN-aware bundle is also supported with this kind of architecture, and not only within a single fabric. You can obviously use this kind of service to extend a broadcast domain between two fabrics. As for any kind of layer 2 extension in a multi-fabric network, the layer 2 VNI needs to be configured on the border leader as well. And because we need to forward Ethernet tag ID all along the path, the VLAN-aware bundle must be configured on those intermediate devices, as you can see on the diagram. Now, let's take a closer look at how we configure a VLAN-aware bundle service. So the configuration for this type of EVPN service requires three mandatory items: the route distinguisher, the route target, and the VLAN we want to map to associate to this AVI. So it is important to note that unlike VLAN-based service, route distinguisher and route targets do not support the auto keyword. It means that we have to specify values for the route distinguisher and for the route targets, knowing that route distinguisher must be unique per VTEP, while route target must be common to all VTEPs sharing this broadcast domain in order to be able to import and export the EVPN route. Optionally, you can also configure if host routes must be redistributed, but also a specific Ethernet tag ID if required. But this part, we will cover that in the next slide. So one key point when configuring VLAN-aware bundles is the management of the Ethernet tag ID. As we said, by default, this value will be set to the VLAN ID associated with the layer 2 VNI. But if required, as an example, if a remote VTEP has a specific value for a given VLAN, you can manually set the Ethernet tag ID to the value you need. To do that, within the bundle context, you only need to use the VLAN Ethernet tag command, specifying the VLAN and the tag ID you want to associate, as you can see on this example, with the tag set to 10.100 and the VLAN 100. Doing a show EVPN EVI, we can now see that the Ethernet tag ID field is not the same than the VLAN. But keep in mind that manipulating Ethernet tag ID, there are some rules to follow. If you need to modify a tag ID, you first need to disable the whole bundle and re-enable it once your change is done. You obviously cannot set a tag to a VLAN which is not declared as a VLAN of your bundle. And finally, you can mix manually and automatically set tags within the same bundle. This is not because you set a tag for a given VLAN that you need to do that for all other VLANs within the same bundle. So as we mentioned, VLAN-aware bundle supports combinations. So first, we can see on the left an example of what we just mentioned. we can see that we do not set a tag for VLAN 111, while we do that for VLAN 110 and 140. On the other side, on the right, it is also important to mention that we support, on the same VTEP, VLAN-aware Bundle Services and VLAN-based services. It means that you can mix VLANs within a same EVI using VLAN-aware Bundle Services and VLAN with their own EVI using VLAN-based services. The next point is regarding VLAN manipulation. So there are three main rules to mention. So first, as we already mentioned, if you need to update the tag related to a VLAN, you must disable the bundle first, make the change, and re-enable the bundle. Then, as we also mentioned, if we need to associate a tag to a VLAN, which is not part of the bundle, we first need to assign the VLAN to the bundle. Then we can associate a different tag. And finally, if we want to assign a VLAN to a bundle, while it's already configured as a VLAN-based service, we first need to delete this latest. Then we can assign this VLAN to the bundle. Last point to note, regarding configuration is obviously the fact that we can manipulate VLAN-aware Bundle Services using AOS-CX REST API. So there is a new endpoint, which is reachable using /system/EVPN/EVPN VLAN-aware bundles, which allows to create, modify, or delete a bundle, as you can see on those examples. There are a few points to note manipulating bundles with API. So first, if we do not specify the key disable, bundle will be automatically enabled. Secondly, you need to give the URI of the VLAN, not only its ID as an integer or as a string. And the last thing is the fact that the key VLAN does not exist. So what does it mean? It means that your VLANs are declared using the VLAN Ethernet tag key, and this key is a dictionary by itself. If you want your tag to be set to the VLAN ID, just put the VLAN ID. If you want your tag to be set to another VLAN, to another value, than the VLAN ID, specify it. You can see an example just right here. Now the best practices. So first, let's look at how we build a bundle. So the first best practice here is to use the same IDs or names on all VTEPs sharing a bundle. So this will obviously help for troubleshooting. The second best practice is to use an ID in the VLAN-aware bundle name and reuse this ID in the route distinguisher and route target definition. This will allow to easily associate EVI or VNI to a bundle. And lastly, prefer to let the system set the Ethernet tag ID to the VLAN ID, except if it's required to set it manually, because you need that to interoperate with another vendor. Using Ethernet tag ID set to VLAN ID will obviously ease the troubleshooting. The second part of the best practice is regarding the bundle configuration update. So remember that when you need to update a bundle configuration, except if it's just to add or remove a VLAN, you need to disable the bundle first. So when you need to do such an update on a bundle, you have to schedule a maintenance window because traffic will be disrupted during your update. And finally, regarding VSX synchronization now. So VLAN-aware bundle being part of the global EVPN configuration, it can be synchronized between VSX peers. So using this capability, it will ensure that the EVPN control plane is consistent across the cluster. But keep in mind as well that both VSX peers have to use the same route distinguisher. So in a VSX context, always use the loopback, which is common to both peers. And this loopback is usually the one that you are using for the logical VTAP capability. Now let's move forward with the troubleshooting part. So in case of an issue, the first step is obviously to check if your VXLAN EVPN-based infrastructure is up and running. So check your topology, ensure your IPs, your interface configuration, check the physical cabling as well, check your underlying network, check the BGP configuration, and obviously check the configuration of your VXLAN interface. Then you also have to check if your layer 2 VNI are created and up, doing a show EVPN EVI summary. If they are not, ensure that your bundle is enabled. The next step is also to check if VTAPs are discovered for a specific layer 2 VNI, and that MAC addresses have been learned. If not, check the configuration on the remote VTAP if a bundle has been configured and enabled. Also, depending on the platform, you can check if the feature VLAN presence client detect is enabled on the remote VTAP. So, because keep in mind that this feature, which is enabled by default on some platforms, drop down a layer 2 VNI if there is no port up for the matching VLAN. Next step is obviously to check the bundle configuration consistency between two VTAPs, and especially the following points. So the route distinguishers must be different between two VTAPs. The route target import and export must be consistent between the two VTAPs. And finally, the Ethernet tag ID must be consistent as well. And finally, check also if the route type 2 and 3 are learned on both sides with the Ethernet tag ID associated to them. This can be done using the show BGP L2VPN EVPN command. Now let's move to the demo. So for this demo, we'll use the setup that you can see on the slide. So we'll use a multi-fabrics environment with, on the right side, our data center using 8325 and 10K as VTAPs. On the left side, our campus using 6300 as VTAP. And we also have two 8325 used as border leaders for each fabric. So the idea of this demo is to use a VLAN 110 with an endpoint connected onto each VTAP into this VLAN, and we will extend it first between the VTAP into the same fabric, so into a data center, and finally across the two fabrics. So let's see that in action. Okay, so as you can see on my desktop, so I have different windows. So on the left side of the screen, so I have different tabs used to connect to the different resources that we are going to use in this demo. So the two first tabs that we are going to use are this one. So I have two remote connections. One remote connection to the VM 110.10, which is connected on VTAP 1, and another tab, which is a remote connection to the VM 110.11, which is connected on VTAP 2, so on this VTAP. And so as you can see, so I launched ping between those two VMs just to test the layer 2 connectivity in real time between those two resources. I also have two SSH connections, one to VTAP 1, so this device, so the 10K is my VTAP 1, and the 8325 that you can see here is my VTAP 2. So let's start the configuration. So just before to begin to start the configuration by itself, let's check some configuration items. So let's do a show run EVPN. Okay, so the first thing that we can observe is the fact that we didn't declare the VLAN 110 in the EVPN configuration yet. So there is nothing related in terms of EVPN, there is nothing related to VLAN 110. And the other thing is also that all the services that we already have are only VLAN-based services. We don't have any VLAN-aware bundle configured yet. So let's check now the VLANs. Okay, so VLAN 110 is already configured on both devices, so that's perfect. And let's check the VXLAN interface configuration. Okay, and we can see that, okay, so the VNI, sorry, 10.110 is already configured for the VLAN 110 on both sides. We can see it here on VTEP 1 and here on VTEP 2. So let's start the configuration. Let's start with VTEP 1 configuration, config. Okay, let me just do a copy and paste, and we will check the configuration. We will have some detailed overview on the configuration just after. Okay, so what did we do? So we entered into the EVPN configuration context. That's perfect. We created our bundle, which has been named extended. We configured the route distinguisher, and we used the loopback one, which is a loopback used also for the logical VTEP capability. You can see here that this loopback is the same than we are using as a source in our interface VXLAN, because our devices, the 10K and the 8225, are used in VSX clusters. After that, we declared two export, so two route target export and two route target import. Why? Because we are using this one as export and this one as import for all imported and export EVPN routes with the other VTEP inside the fabric. And we are going to use this one, so this import and this export, when we will have to import and export EVPN routes with other VTEPs in any other fabric. We are also redistributing host routes, and we have associated our VLAN 110 with this bundle. So let me just refresh my connection. Sorry for that. It's perfect. Okay. So we have done the configuration on the VTEP A. Let's do that also on VTEP B. Config. Okay, and you can see now on the connection, on the remote connection to the resources, to the servers, that now both servers have layer 2 connectivity to the other server. Okay, so that's perfect. Let's just check some items. Let's do, sorry, show EVPN. VNI, EVI, sorry, EVI detail. Okay, and here you can see that our layer 2 VNI 10.110 is configured with the route distinguisher that we have configured, obviously, the VLAN 110, and you can see the Ethernet tag ID. And if you look at the configuration, we didn't declare a specific Ethernet tag ID for this VLAN. So it means that it has been automatically set to the VLAN ID by itself. We retrieve the route target import, export, and we can see that the other VTEP, so VTEP 1 or VTEP 2, depending on which VTEP we are looking at, we are, as a peer VTEP address, we are seeing the other VTEP, obviously. Okay, so that was for, oh, let's do just, sorry, show BGP L2 VPN, EVPN, VNI. Okay, I forgot that command. And you can see also that for the layer, for the route type 2, now we have an Ethernet tag ID, which is set in the output of the command. Okay. So now let's move forward and let's extend this VLAN, so the VLAN 110, from this fabric to the other fabric. And so for that, as you can see, I have also a remote connection to a Windows client, which is here. Okay, and so I launched a ping to one of the servers. So this server, this client is also in the same subnet, in the same IP range. And so we will see in real time when the connectivity between this client to the other server, to the servers, will be up and running. So let's move to the configuration of the endpoint, to the 6300, which is my access VTEP here, and also the two border leaders that we have on each side, on each fabric. So let's start with the border leader in the data center. Let's do the configuration. Oh, let's just maybe check some configuration items, sorry. Show run EVPN. Okay, so you can see also that on the access VTEP side, I don't have any VLAN-aware bundle already configured, and VLAN 100 is not declared in my EVPN configuration. On the border leader side, I don't have any service already declared because as of today, those border leaders are not used to extend layer 2 subnet between two different fabrics. So we don't have to declare, to create, to configure, sorry, the VLANs. We didn't have, sorry, to create some VLANs onto those border leaders because we didn't need this layer 2 extension. So let's start. Let's start with, as I mentioned, the data center border leader configure. Okay, let's extend a little bit the window. Okay, let's do the same thing on the border leader of the campus. Config, perfect. And now we just have to finish with the configuration, the creation of the bundle on the access VTEP. That's it. And now you can see that I have a layer 2 connectivity between this endpoint, which is connected on my fabric, in my fabric one, so in my campus. And so I have a layer 2 connectivity to both of the servers. So here I'm just pinging the 110.11, but let's check with the other one. Oh, sorry. And that works. Okay. So now I have my layer 2 connectivity between all my fabrics. Let's just make a little check on the access VTEP, show BGP, L2 VPN, EVPN, VNI. Okay. And so you can see, especially here, that I have my route type 2, which are learned from the other fabric, because I have here the AS number of the other fabric. So with the Ethernet tag ID 110. So that's it for the demo. Now, the scalability and performance numbers. So because VLAN-aware Bundle Service is just a way to operate, it doesn't have any impact on the EVPN scalability. So there is no change to the current EVPN scalability numbers. On the other side, in terms of number of bundles that we can create, there is no specific limit. Thanks a lot for your attention, and see you later.